So virtualization is another technology that typically people have on-premise. How many of you guys are using virtualized servers in your environment today? Very few. All right, so a virtual server is basically a server it's a virtual operating system like Windows or Linux, but it runs on the same piece of hardware. Let me get the next slide real quick. So in your traditional architecture, you would have a piece of hardware, you'd load your operating system on that, and then you'd load your applications on that, like Exchange or SQL or whatever application you're using. Forgive me, we use VMware. There's actually different types of virtualization. There's Citrix, there's Microsoft Hyper-V, and there's VMware. So we're a VMware shop. So in the VMware scenario, you take your piece of hardware, which looks just like your regular server that you have now. You install VMware on it, and then on top of VMware, you install multiple operating systems. You can have multiple copies of Windows, multiple copies of Linux, running on the same piece of hardware. Go back to the first slide, the other side. Cool. So some of the advantages, there are advantages outside of business continuity and disaster recovery. You're obviously taking up a smaller footprint, using less power and cooling. You're having, depending on the scale of your box, you can have 40 servers running on one physical piece of hardware. So you take a rack that actually looked very impressive to your CEOs, and you made it very, very small, which doesn't look that impressive, but you can leave the other ones on and tell them they're doing things. So you can also, scale is much better. So now when you need to add more servers, one additional server could represent an additional 10, 30, whatever servers, depending on size. And of course, provisioning those servers is very quick. You can actually copy servers. Same way you guys have a template for an Excel document, you can actually copy a server and deploy it literally in minutes versus days of ordering hardware, installing applications. That doesn't happen anymore. Go to the final slide. I'm going to do this kind of quick. So some of the advantages from a business continuity and disaster recovery perspective is that you're separating what you're running, which is your business services like SQL and Exchange, so your email, your accounting application, you're separating it from the hardware that it runs on. So hardware lives in a place. You don't, in a disaster, you don't go to that place, pick up the hardware, and run out to another place. With virtualization, you can have these servers literally moving between data centers virtually. So you can have a failure in, let's say, your New York facility, and if you have a Rochester facility or Chicago facility or wherever you are, you can bring servers up virtually. The same servers, can either automated or manually, can just come up in that other data center, and depending on your own plan, you can either work remotely, you can have another office that they stay online. So it's a cloud-ready system. There's other options with respect to recovering in the cloud. So even if you don't, as Sri mentioned about leveraging your vendors, let's say you don't have multiple data centers. Let's say you have virtual servers in your environment, or even physical servers, and you have a disaster and you need to recover. Well, one of the options is to recover virtually in the cloud, to spin those servers up at a temporary facility provided for you, and then turn them off when business resumes as normal. And of course, remote workforce ready, because these are distributed applications. You can have people working from home, working from their iPads, their iPhones. There's really no restriction. Their laptops. You can be accomplishing the same level of productivity that you do in the office as you do during a disaster.
So the virtualization, we took some stuff out here. It goes beyond the servers, right?
You talk about desktops.
You talk about the desktops. For example, we've got thousands of virtual desktops at Stony Brook that the students actually tap into from anything. They tap in from here. But what they're really doing is tapping into a virtual desktop that looks and feels and does exactly what a real desktop will do, but they're sharing the infrastructure like we talked about before. For those of you that have been around a long time, almost think mainframe, right? It's kind of mainframe on steroids. It is. It's a throwback to the mainframe days. But now the technology's come full circle. Again, I would encourage you to have conversations with your IT folks about virtualization, because the savings on virtualization that you can get are huge.
And your full computer on devices like this.
Yes.
It really changes the landscape.
Thanks. So, Sri, you want to talk about data connectivity?
Sure. Data connectivity, goes hand in hand with the stuff that we talked about, VoIP, but it goes further than that in that it pretty much represents your lifeline to the outside world. There's different types of connections. I'm sure you've heard of practically all of them. Metro Ethernet is jargon for a larger than a T1 service, and it's using Ethernet as its media to be able to deliver these services. So you can have Ethernet over copper, you can have a fiber circuit, as your Metro Ethernet offers. There's TDM, which is your T1s, your DS3s, your OC3s, your copper and fiber-based services that terminate onto different types of hardware. Then you have your broadband stuff, and a lot of people in Long Island I know that use Cablevision as one of their providers. But there's also FiOS, there's DSL, those type of broadband connections. And then there's on the wholly different end, the wireless spectrum, where you have your 4G cards that go into routers that are using LTE from Verizon or AT&T. Then you have like your tower stream type of products, which are microcell antennas on your roof or outside of your window that have line of sight connectivity to their POPs. These are important distinctions between the type of last mile service that you're getting provided because of redundancies that are required in your organization. So let's say you have a T1 as your primary internet connection. It doesn't make sense, number one, to get another T1 from the same service provider because it's likely on the same pole, it's likely on the same DS3, it's likely the same copper, and so everywhere you just don't have any redundancy there. You have single points of failure all throughout that. Additionally, if you're going to get a T1 and a T1 from another service provider, same issue, because they're both using Verizon copper. So you kind of want to have both of those things segregated. In my estimation, you always want to use a different cabling plan or a different last mile solution as your redundant provider. And that means using cable as your primary, which is a coax infrastructure in the ground, and then using copper as a backup, or using a tower stream type of service as a backup. Those are the kind of real redundancies that you have. You have redundancy at the service provider level, and you have redundancies at the cabling plan or facility level. So even if somebody cuts the copper in the building, you still have the coax going out, or vice versa. And with microwave, we can cut the air, but you have a higher level of redundancy there. Types of redundancies we can go into are, on the high end you have BGP, which is a routing protocol for large circuits that you can route traffic between the two or advertise specific routes going this way and this way. HSRP is more of a hardware redundancy where you have each circuit coming into two different pieces of equipment, and those two pieces of equipment are talking to one another saying, hey, who's up, who's down? Make sure that you're routing out the right circuit. By using like a hardware type of redundancy there, you're also limiting your single points of failure because now you have two pieces of equipment terminating two circuits. And again, that might be way too much for some people, but it might also be really important for others. And as I mentioned, multiple service providers is really important. Diverse cabling plans or last mile services are also really important.
Thanks.
And that's kind of an idea of what that should look like in the most basic of terms.
Well,
Yep. Data connectivity.
It's the same thing.
so I'll run through cloud.
Very quickly,
Yeah.
wrapping up with cloud.
Yep. So cloud is sort of BCDR ready, I guess. If you guys, how many of you guys are using like a cloud application as your main application, like a NetSuite or a Salesforce? No. Right. So a cloud service, there's different types of cloud services. So there's software as a service, which Salesforce is an example of, NetSuite's an example of. It's a hosted application. You do nothing but go to a web page, log in, and do what you got to do. Platform as a service is a little more obscure. Microsoft Azure, these database hosted platforms, not a lot of people are using them. And then infrastructure as a service would be, in a data center, people providing you virtual servers that are hosted out of their data centers. So during an outage like Sandy, these services are already theoretically ready to survive these hits. They're already across multiple data centers. Your access methods are a web browser, anywhere you have internet. So if you have a workforce that goes to an office, goes to a website, logs in, does their accounting application, does their Salesforce application, in a disaster, they could do this from home, they could do this from a hot site. There really is no change at all in what they do day to day. We use NetSuite, for example, as our accounting. I'm as effective from my house, from a hotel room, as I am from my office. There's literally zero difference. These are just examples of different types of the cloud. I'm surprised that more people aren't using even Salesforce or some of these other systems, but they're out there, and if you switch to them, you really are offloading the the business continuity planning to another provider. There's really very little for you to do on your side, but just log in and use the application.
You know, some of the other benefits there are you're taking advantage of the best practices that these professionals that provide these services for a living, they're constantly looking, what are our, not just you, but what are our customers looking, what's our customer base looking for? And they're constantly improving these service offerings to include those best practices. So, you know, it's different from the traditional, I buy an application, and again in the SaaS world, I buy an application, I install it, I upgrade it when I'm ready to upgrade it, and I support it. In this case, it's a fluid application that you tap into, and the service provider is upgrading it. The service provider is constantly improving it.
Yeah, I log in next Tuesday and I have new stuff.
There's new functionality. It's a new way of doing business, but you go on and you say, wow, it does this now. I've been thinking about doing that. I could do that in this application.
Less cumbersome, right? Less cumbersome.
Well, less cumbersome to support,
Right.
but you need to refocus your efforts on
Management,
Management.
connectivity, and things like
Yeah,
that.
yeah.
Right. Well, one thing that the cloud has as a downside is that connectivity is everything. If you're accessing an application through a web browser and you lose your internet, your whole business could stop or that application could go down. And I'll just close by saying, of course, the cloud is a marketing term, and there is no technical definition from our IT perspective of what the cloud means. It means many things to different people, and everything is, we used to call it the internet, now they call it the cloud. And I'm talking about reputable cloud providers. I'm not talking about every guy who's throwing up a server in his house and saying it's a cloud server. I'm talking about your Rackspaces, providers like us, like Shri, NetSuite, Salesforce. These guys they have those plans in place for their own redundancy. So that's important to know.